Hello everybody. Been a little while since I've given you a video to watch, so let's go ahead and give you a nice easy one. Today we're going to be talking about partial derivatives. Now, partial derivatives is when you're taking the derivatives with respect to one variable instead of your single variable. These will only really show up if your function has multiple variables within it. So if your function is just f of x, yeah, it's just a straight derivative. There's no real partials. But if your function is f of x and y, then yes, you will have two separate partial derivatives. All right. Now, each of these are separate. Keep that in mind. But they're still pretty straightforward. All you do is take the derivative of one of your functions with respect to one of the variables. Now, if you refer back to what we did for implicit derivatives, it's about the same type of stuff. We're just not adding the two things together. So any variable which is not taking the derivative of at that time, you just treat it as a constant. So if your function is just xy, well, when you take the derivative with x, y is treated as a constant, in which case the derivative with respect to x would just be y, and vice versa with the derivative with respect to y. Now, notation-wise, we no longer use the d's, we're using del's. It's a little bit funky, but it's to note that it's a partial derivative instead of an actual full derivative. All right, so you'd write the del f over del x. All right, so let's go ahead and give you an exercise to try out. I want you to find all the partial derivatives of this function here. All right, hopefully you've tried that out. Now, for the partial with respect to x, it might help you to rewrite it as this. So you have all your constant terms, then you have all your terms that are coefficients of just x. And hopefully this might help you if you were having issues. So try and find the derivative of this. Okay, hopefully you've done it, and you should get 20 plus 0.1y, the coefficient in front of your x term. All right, now go ahead and try it with y. Hopefully you've done so. Again, you can rewrite it like this, might help out, and it's pretty easy to see from here that your derivative is going to be 40 plus 0.1x. So you have a different derivative regarding determining what variable you're taking the derivative with respect to. Now, another side note for related rate problems, i.e. where you're taking the derivative with respect to time, you're still able to do that, and you'll come out with an actual derivative with just respect to time. But you'll have to do something like this. So you have to find the partial with respect to each variable, and then multiply it by its derivative with respect to time, and that'll give you the derivative of your cost function with respect to time. All right, I will see you in class.